Hello, this is Sean Mallory from Electronic Engineering at IT Sligo, and what I'm going to cover in this lesson is information about a structure or a system called a linked list. Okay, now a linked list is a little bit like an array in that we can have lots of different items in it, but normally what we would have in this is we would have this would be like an array of structures, if you can imagine such a thing. And you can make an array of structures. There's no harm in doing that. But the problem is that in many cases we don't know how many items we want in a list. Okay, so we don't know how many items we might want in an array, and therefore we might want something that can grow in size. Okay, so that's what a linked list is. It's a list of items that are linked together, and we can add new links to it in order to have a larger list of items, or we can delete an item from the list. As well as that, we can also structure it in such a way that when we add an item to the list, that we might add it in numerical order or alphabetical order, so we could insert it in the middle of the list, and that's no problem. Now, the thing about a linked list is that unlike an array, it's not set out in memory one item after another. So you can't just increment into it like you would with the index of an array, where you index into an individual element or whatever. Instead, with a linked list, what you have to do is a little bit like a chain. You have to move along it and jump from point to point to point until you find the one that you're looking for. Now, linked lists are quite complex to understand, particularly the first time you see them. And so what I'm going to do is I'm firstly going to show you this computer program that I've written here, and it's basically a copy of a computer program from the one of the recommended textbooks that I've mentioned to you, See How to Program by Paul and Harvey Deitel, and it's the 6th edition that I'm using here, and linked lists are covered on page 490 onwards, and this program is on page 490 on, but it's on for about 3.5 pages or nearly 4 pages. And so I've rewritten it out here almost the exact same as it's written. The only thing is I've left out comments because obviously I'm going to be explaining each point along the way, so I don't want the comments getting in the way from that point of view. And so what I'm going to do is I'm going to talk you through how this program works, but I'm going to do it in stages, so I'm going to do it in several different videos. And all I'm going to do in the first video is try to explain to you a little bit about the linked list, how it works, and then show you the program in operation. What I'll then do over the next series of videos is that I look at individual functions within it and how they work, so that if you're going back to understand a particular function or whatever, that you don't have to watch an entire big long video, because it'll probably take a considerable amount of time to go through it all. So firstly, the whole point about a linked list is that each link in the list must have the capability to link to the next link. Okay, and so we do that with the structure the struct that we've used previously, and I've made this struct, or the Deitel have made this struct very, very simple in order that we kind of stick to the understanding of the linked list procedure. But then after that we can make much more complex structures that just have a link to the next structure along the way. Okay, now all these structs should be the same. So if we look at the definition of the struct here, we've called it a node, as if each element along the way is a node. Okay, but that's just a name that we've given it. There's nothing particularly special about it. And we've just got one variable within inside that structure, at least one variable that actually has information in it. There are 2 variables, as you'll see here in a moment. But one variable that actually has data or information in it, and it's just a single character. So we really couldn't have a more simpler struct than that. And you might think to yourself, well, what's the point in having a struct that only has one character inside it? And it's purely to try and keep this as simple as possible, and then you can make more complex versions of it. Now, so that's our character there, as you can see there, and it's called data. Now, what we then have also inside the struct is we have another struct. And the strange thing about the other struct is that it's also called list node. So it's effectively like I'm making one of these inside itself. Okay, except for the fact that this isn't an actual full struct itself, it's only a pointer to one. Okay, so I've called this next PTR, and it's a pointer to a list node. Now this is inside a list node already, so it seems a bit strange what's going on there. What you have to understand is that this is a linked list. So it has its data, so its information, which is there, but it also has to have a pointer to another item of the same type so that it can go and find it and it can then move through it. And that other item, that other list node, will also have a pointer to the next list node along the linked list, or along the set of links that we have, right up until the point that it finds a pointer, or that we find a pointer that's pointed to nothing or pointed to null, and then we know we've reached the end of the chain, we've reached the end of the list. So the important point about this is that these nodes can be stored anywhere in memory. Okay, so they don't have to be stored in one after the other or anything like that. They can pop up all over the place, and as long as we have a pointer, we can hop from one to the other to the other to the other until we get to the end of the list. Okay, and there are more complex versions of the linked list, such as a doubly linked list, which means that you can hop back the way. In this particular system, you can only traverse it in the forward direction. So what we normally have is a kind of a head and a tail to these linked lists, so that we start at one end and we make it as far as the tail. But if we want to go down through the list, we always have to start at the top and then start to move from there. Okay, so that's the idea. Now what I'm going to do is as I said, it can only take one piece of data. So this is quite a long program. There are 159 lines in it. Okay, so it'll take me a while to go through it all. But I'm just going to run it here first so that you see what happens. So you can see the options that are being given to us there. Enter your choice. 1, we want to insert an element into the list. 2, we want to delete an element from the list. And 3, to end altogether. Okay. Now this has the same issue that I mentioned in one of the forum posts, which is that there is a system there that if we put in an invalid input, such as 4 or 5, or any other number, that it'll tell us it's an invalid input, and it will allow us to re-input the information. But if we put in something like a letter or something that it's not expecting, it does mess up the program. Okay, and we haven't put in the code to try and solve that situation, because it would overly it would take away from the understanding of the linked list. So I've deliberately not gone and put that in. But if you're writing your own, perfectly fine to go and put that in and try and make it as foolproof as possible. So I'm going to add an item to the list by pressing 1, and I'm going to enter a character, and I'm going to stick to all uppercase letters here for the moment. So I'm going to enter the character S, and it's printed out the list for me now, and it just said S is the only item in the list, and then it points to null. In other words, null is the end of the list. Now the little question mark has come up again. It wants me to enter another input. So do I want 1, 2 or 3? Do I want to insert or delete or to end? I'm going to insert another number, or another letter, sorry, and this time I'm going to insert the letter, we'll go for X, and you can see here that it's now got S, X, and then null. Okay, so it's now got a list of 2 letters and then the null. And the thing is that these are in alphabetical order. So what happens if I put in something that's before S in the alphabet? So again, I want to insert something, and I'm going to put in the letter E. And we can see that it's clever enough to put E at the beginning, and then S, and then X. So what it's done in this particular case is that it's figured that capital E is before a capital S in the alphabet, and therefore it's going to put it in that order. Now, there's a little bit of an issue if I then go and decide to put in a lowercase letter, like B, because you can see it's put B at the end, and this is because it's actually sorting them in ASCII order rather than alphabetical order, and therefore a small b is a higher up number in the overall list than the capital letters, and therefore that's why it's been put at the end. And if we put an A in here, you can see that A has gone ahead of B, but it's not gone ahead of the uppercase letters. Now, what I'm going to do is I'm just going to put in 1 or 2 more letters. So I'm going to put in the letter G, put in a capital G. Sorry. Okay, and the G has gone in there, and I'll put in 1 more, and I'll put in the letter I. Okay, so we can see all those letters in, and this can grow and grow and grow literally until we run out of memory. And of course on a PC that's unlikely to happen very easily with us just typing in values. We'd be typing for a very long time. Now, some of the other options that were there were the number 2 to delete. So I'm going to delete an item, and it says, what character would you like to delete? So I'm going to delete the character G. Okay. And you can see it has done that. It now goes from E straight to I, and it moved around G, and G is now gone from the list, and it's taken it all out. What happens if I put in a letter, if I ask to delete a letter that isn't in it? Well, let's check. And it says H is not found. So it's gone through the list, it hasn't found H, it's told me I can't delete H from it because it's not there. Okay, so this is quite a clever program with regard to setting up the size. And you can imagine that you could have a much larger structure, such as the employee struct, which would rank employees in terms of the alphabetical order of their surname, for example, or their first name. And you could add new employees to the list, and you could have your full list of employees, and you could print them out at any stage. And obviously, if an employee leaves, you could then delete that employee from the list, and so on. So there are much more complex versions of this that you can do. Okay. What I'm going to do there, just to end, is I'm going to use the number 3. Well, actually, what I'll do is I'll just put in an invalid one first, 7, so that you see it. Invalid choice. Enter 1, 2, or 3. I'm going to enter 3 because I want to end. And that's the program ended. Okay, so that's what the linked list looks like, and that's how we're going to print it out and so on. What I'm going to do in the next lecture is I'm going to start to explain how we go about operating this program. Okay.